Good morning. This is Mr. Clancy, and I wanted to help you with your preparation for the AP Environmental Science exam by going over the review sheet. This is 100, I think there's 157 of these interesting factoids about environmental science. And this is basically a compilation of everything that we have talked about this year. So I thought I would take this opportunity to go through this with you instead of just giving you the review sheet and say, here, reading it. I thought I would make a video for it. That way I could use some examples. You could hear my voice explaining some of the stuff and so forth. And we'll break it up into a couple of different videos themselves. But basically, I'm here to help you. And by going over this, not only but later on going over it as well, the videos I should say, I think this will really help you in your scoring on the A.P.E.S exam. I'm very proud of the work, I should add, that you guys have done this year. I know I've asked you to do a lot in this AP course. We've had a lot of, we've learned a lot of good stuff, I think, this particular year. And so I'm looking forward to helping you prepare and using this tool to help you prepare to the very best of my ability. These factoids, if you will, or definitions, are basically really mixed. So you're gonna see some pertain to energy. You'll see that some pertain to topics that we learned about this year. So you'll see, for example, that some of them will pertain to Earth systems and resources, and they'll be talking about these. This is really was our first unit in the year, and we talked about geology and tectonics, tectonic plates and so forth, and the soil and the dirt, where the dirt comes from and so forth. You'll see some of them will be with the living world. Again, these percentages would be the percent of exam questions. At least on the multiple choice. So out of 100 multiple choice questions, you would definitely have, let's say, 10 to 15 on the living world. This is really on ecosystems and energy flow. We did a lot of nice, you guys did a lot of nice work on this with the eco columns, where you saw the fish and so forth. You had the decomposition chamber, had a lot of grass that grew and so forth. We got to see the nitrogen cycle in effect there when we were checking for nitrates and phosphates and stuff like that. You will also see some of these questions pertain to populations, where we talked about human population. Remember, this is the biggest single problem facing the environment. The biggest issue is population growth. And if you keep that at the basis of all your studying, I think you'll find it'll really help you out a lot. If we have more, just if you make the connections, if we have more people, that means we have to feed more people. If we're going to feed more people, we need more land, or we need to look at more efficient ways to grow crops. If we need more land, that can lead to things like deforestation, which if I cut the trees down, or if I burn the trees down, it leads to pollution issues. It also leads to a problem with global warming, because with basically the whole energy flow system is reduced. Remember, photosynthesis takes up carbon dioxide. All right, and photosynthesis is basically conducted by trees and plants. And if we have fewer trees, we've got a lower or diminished capacity to conduct photosynthesis. So always be thinking in those terms, all right? You really want to be thinking at the basis of everything is population, or handling population growth. You'll see some of them also refer to question of factoids will be with land and water use, again 10 to 15%. This is some of the stuff that we've had a chance to talk about with trees, controlling pests. We looked at integrated pest management here. You guys did a nice job with that. We're going to look at relevant laws in this particular, going over some of the facts as well within these factoids, if you will. Sometimes these factoids were referred to as 157 reasons to go ape. So urbanization would be the growth to the cities or migration to the cities. All right, if we have a lot of people in a relatively small area, we'll call it densely populated areas. All right, how does all that fit in with environmental science? How do we handle food? How do we get food into densely populated areas? How do we remove trash? What do the ecosystems look like in that area? So those are things we want to be thinking about. You will also see some of the questions relate to energy resources and consumption. And this one we talked about basic fossil fuels, how they are finite resources. And fossil fuels are basically limited in quantity. All right, so fossil fuels are finite. Sometime we're going to run out, particularly at the rate at which we consume these fossil fuels. We got to make sure we've got a good feel for that. And that leads us to talking about making energy from areas other than using fossil fuels. That's when you get into things like nuclear energy, hydroelectric power with dams. Can we conserve energy? You have to ask ourselves, are we really using too much energy? Maybe we can get by with a little bit less. What would happen if if the United States cut their energy consumption, let's say by 5%? This would have I'm just posing this particular question. This would have a huge impact on our energy picture. Could we do it? Think about yourself. Could you reduce your energy consumption by 5% in everything that you do? It's something to think about. The other unit was pollution, and this is a bigger unit. You'll see this is 25, a little over a quarter, at least a quarter of the questions would come from pollution. And pollution, we need to think about air pollution. We need to think about pollution of the dirt, and we need to think about pollution of the water. And we also need to think about how the pollution of the air intersects with the pollution of the dirt, how the pollution of the dirt intersects with the pollution of the water, and so forth. And water pollution, solid waste, and so forth. How do we get rid of waste? This gets into things like recycling, which very few are still, to this day, a very small percentage of our populace as a whole recycles. It seems incredible with the awareness on recycling and so forth, but they do. Very few people still do it, and it can greatly benefit us. The other thing is global change, and or really climate change. It should be. What's the implication? What causes global change? What can we do about it? Some of it is stratospheric ozone, as we've talked about. Remember, this is O3. And some of it is global warming, which is with, in effect, using more energy. And this comes, when we use more energy, the power plants work harder. All right, and unless it's a nuclear power plant, that means they're producing a lot of CO2, because whenever I burn a fossil fuel, this can be natural gas, this can be oil, this can be coal. All right, plus oxygen. If I usually produce two products. Now, one of these is carbon dioxide. The other one is water vapor. All right, these are the combustion products, we'll call them. All right, and the CO2 is the one that traps that basically radiates from the Earth, or is not absorbed by the Earth, I should say. And in effect warms up our atmosphere. So this is the one that can lead to global warming. And that's the big concern. All right, basically, if you remember, called a GHG, which is a greenhouse gas. All right, so a greenhouse gas, there are other greenhouse gases. One would be methane, CH4. We'll call this types. Another one is nitrous oxides. Also, another one is water vapor itself. And remember, our Creator designed our atmosphere to warm us up a little bit with some water. As part of the global warming is by design. The big issue is right here with carbon dioxide. Are we using too much energy with cars, with factories? This would be as an offshoot of many, let's just say, many cars. Most of us have, there's usually 3 to 4 cars in every house now. I can remember growing up, we had 2 cars. That's all we had. When my sister and I got one in high school, that was the 3rd. But, we had a big family. So basically my mom had one, my dad had one. Now we've got multiple kids and families. They each have cars in some situations. This is also a offshoot, if you will, of the Industrial Revolution. All right, so in other words, the Industrial Revolution really changed our whole society. It gave the United States the power, economic power that we now enjoy as a superpower, but at what cost? And one of the big costs was the environmental costs, damage to the environment. All right, so that's really what we have to ask ourselves. Can we make things more? And we've made a lot of progress as a society in our industrial facilities and making things more efficiently. But can we continue to do that? That's the big thing that's going to be we have to address as individually and collectively in the future. By the way, you should have a copy of this A.P.E.S topic sheet. I'll put one on for you, or if you would like a copy. A hard copy, do let me know. I'd be delighted to get you one. I think I passed them out earlier in the year. But, all right, let's go ahead and look at a few of these. I've got a couple of illustrations that I want to share with you as well. And just as kind of a reminder, as a kind of a refresher, I guess. I don't know about you. It's hard for me sometimes to remember what I ate for lunch yesterday, let alone remember something we learned in environmental science in August. But what I'm hopeful for is that once we have a chance to brush up and review, we will remember it. When you're in college in the fall, and you juniors, when you're in the college a year from the fall, you will find you'll have to take exams that are basically, they're going to ask you in December something you learned in August. You're going to be responsible for a whole semester's worth of learning. And so this is part of kind of one of the reasons we have this course is really to prep you for college. And the real secret is if you learned it right the first time, when you review it, it'll come back. And I think you guys have demonstrated a good prowess here. Anyway, let's go over a few of these. The first and second law of thermodynamics. These are, I think you guys should be reasonably familiar, is conservation of energy. So energy never changes. The total quantity never changes, all right? I'll just put total energy never changes. Energy just changes form. All right, so it may go from a useful form of energy which we'll see below in just a second, to a non-useful, if you will, form of energy, which is typically heat dissipated, excess heat that goes off. So energy may be converted from one form to another. So you could be thinking of some examples. When you drive your car, there's an example of chemical energy in gasoline being converted to mechanical energy to drive your car. Photosynthesis, solar energy into chemical energy, and so forth. So I think you get the idea with that. By the way, the one activity we did right at the start of this semester was that relay rice. I asked you guys that activity just to get in a line and, in effect, pass a certain quantity of rice from one person to another very quickly. The rice itself, in that case, the total amount of rice was the quantity of energy that you started with. The point was, when you passed it from one person to another, that passing was tantamount to a change